Welcome to The Explainer. Think about how much AI you use every single day, whether it's in your photo apps or the tools you use for work. It's everywhere. But what if the very AI models that power all that stuff have a hidden, kind of dangerous side? Today, we're going to dig into how we secure the AI supply chain.
Let's just kick things off with this line from a recent Google report, because it's pretty chilling. The AI models you download, the ones you build your own projects on, they might not be what they seem. They could literally be a Trojan horse, hiding malicious code behind a helpful-looking facade. And that, right there, brings up a huge question that really affects all of us. It doesn't matter if you're a developer, a big business, or just someone using an app on your phone. The question is the same for everybody. How can we actually trust the AI we're relying on every day? So, where does this problem even come from? Well, to really get a handle on the unique risks that come with AI, it helps to first take a step back and look at how we've been building and securing, regular software for years. That's really where the story starts. And listen, this isn't some theoretical what-if scenario. This is real. Just last year, researchers found actual malicious AI models out in the wild on popular hubs like Hugging Face. They looked totally legit, but they were built to do nasty stuff, like steal your data or open up a backdoor for an attacker. All right, let's start with what we know. Think about making traditional software, like following a recipe. We've been doing this for a long time, and we've gotten pretty good at understanding the ingredients and the steps to make sure the final product is safe. It's a life cycle that's probably familiar to a lot of you. You've got a developer who writes some code, that code gets built and packaged up with all its dependencies, and then it gets deployed so people can use it. Seems pretty straightforward, right? Well, here's the catch. That whole process is just full of potential weak spots. An attacker doesn't need to pull off some super complex hack to break down the front door. They can just poison the well, They can sneak in bad code, compromise the system that builds the software, or tamper with a package you download. There are vulnerabilities pretty much everywhere. Now, one of our key defenses against this kind of thing is something called an SBM. That stands for Software Bill of Materials. The best way to think of it is just like an ingredients list on a package of food. It tells you exactly what's inside your software, so you can keep an eye out for any bad ingredients, any vulnerabilities.
Okay, so that's the traditional recipe. Now, what happens when we jump into the world of AI? Well, it turns out AI adds some really powerful and kinda dangerous new ingredients to the whole mix, and that changes everything. At first glance, this looks pretty similar, doesn't it? You've got code, you train a model, you deploy it. But look closer at what's going into it. We're talking about massive datasets, pre-trained models someone else built, and really complex frameworks. This is where the new risks start to creep in. And those new inputs, man, they open up a whole new can of worms. These are totally new ways for bad guys to attack a system. They don't just have to target the code anymore. Now they can do things like poison the training data, literally corrupting the AI's brain before it's even fully formed. Or they could mess with that pre-trained model you downloaded and hide a vulnerability inside. This all really boils down to a huge difference in control. With regular software, we've got great systems for reviewing every single line of code. But how do you review a data set that has billions of entries? It's a massive, almost impossible challenge. Plus, training an AI model takes a ton of time and money, so you can't just scrap it and start over if you find a problem late in the game. So, with all these new risks that are so hard to track, how in the world do we build trust in an AI model? Well, the solution centers on a concept called provenance. Provenance is basically a secure, verifiable receipt for your AI. Think of it as a digital birth certificate. It's this tamper-proof record that tells you the complete story of a model, what data it was trained on, what code was used, who made it, and exactly how they made it. It proves where it came from. And it's not just about a list of ingredients. When we say signed provenance, we're talking about using cryptography to guarantee that the record is authentic and hasn't been messed with. This gives you a trustworthy story of not just what is in the model, but the entire secure process of how it was actually created. So how do you actually do this? It really breaks down into 4 main steps. First, you just capture all the metadata, the who, what, when, and where of the model's creation. Step 2, you lock it all down with a cryptographic signature so no one can tamper with it. Third, you make all that information easy to search through so you can spot risks. And finally, you share it. You use things like model cards to be transparent and build trust with everyone else. Look, securing AI isn't just a job for a few security experts at the big tech companies. Not at all. Everyone who's involved in building or even just using technology has a part to play in this whole ecosystem. It's on all of us. So what are the big takeaways here? First, we have to start treating AI models with the same security seriousness as any other software. You have to understand that datasets are a huge, critical new dependency with their own risks. You should demand and use provenance for any AI model you build or use. And finally, we all need to push for more transparency to build an AI ecosystem that's secure for everybody. We'll leave you with this final thought. Securing the AI supply chain, it's not just some technical problem for engineers to solve. It's about making sure the very foundation of the world we're building, a world powered by AI, is safe and trustworthy. So as AI builds our future, the real question is, who's checking the blueprints?